Hello, I'm Brian Farrell, and welcome to PACE IT's session on cables and connections. Today we're going to be talking about internal cables and connections, then we're going to talk about external cables and connections, and then we have a special category, display device cables and connections. And with that, let's go ahead and begin this discussion. And of course, we're going to begin by talking about internal cables and connections. And we start with the truly ancient, the floppy disk drive cable and connection. Now the FDD cable has 34 wires and it has 34 pins on the connection. You can connect up to 2 floppy disk drives per cable, with the higher priority going to the device that connects after the twist in the cable. That would be your A drive. Then we move to the PATA cable and connection, the parallel AT attachment. Now PATA has 2 basic standards, the integrated drive electronics, the IDE, and the enhanced integrated drive electronics, the EIDE. Now the IDE cable contains 40 wires and the connector has 40 pins. Up to 2 PATA devices can be connected per cable, with the priority for the device being set by jumpers. Now an EIDE cable looks very similar to an IDE cable, but it contains 80 wires, but it still has a 40-pin connector. It is backwards compatible with IDE, but it allows for higher throughput. Both IDE and EIDE have a maximum cable length of 18 inches. Now moving on to more modern standards, we have the serial AT attachment, the SATA cable. Now this cable contains 7 wires with 7 pins. Only one device can be connected per cable, with the priority for SATA devices being set in the BIOS. The connector is L-shaped, so it can only be inserted one way. That's a keyed connector. Now let's move on to external cables and connections. Following the same pattern, we're going to begin with the old and work our way towards the new. And we begin with the serial cable and connection. The most common cable and connection is the 9-pin connector. This connector is often called a DB9, or it's often called an RS-232 connector. That's after the RS-232 serial communication standard. Then there's the parallel cable and connection. The most common cable and connection is the 25-pin connector, and guess what it's commonly called? It's commonly called a DB25. Then we have the PS2, the Personal System 2 connection, which can also be called a mini DIN6 connection. It was most often used to connect a mouse and or a keyboard to the PC. In most cases, the in not connected to the PC was hardwired into the actual device. It uses a keyed 6-pin connector. Now you'll be hard-pressed to buy a modern PC that has a PS2 connection. Now let's move on to the Small Computer System Interface, the SCSI interface. SCSI is a standard that involves how peripheral devices communicate with the PC. It's been around for a while, so it's been implemented through various cables and connections. The most common cable used in implementing SCSI is a ribbon cable that has 2 or more connections on it. The most common SCSI connectors are the 68-pin, the 50-pin, and the 25-pin connection. You need to know what your device and interface is when you are installing SCSI. Now let's move on to sound connections. In most cases, the connection to speakers, microphones, and subwoofers is made through a cable that plugs into jacks on the back of the PC, providing an analog audio sound. And what that means is that each cable carries a single sound channel. The jacks and the connector are called tip ring sleeve connectors, TRS connectors. Another type of sound connection is the Sony Philips digital interface format, the SPDIF connector. These can come in slightly different forms, but they all do the same thing. They will provide digital sound over a single cable. Now let's move on to network connections, and we begin with the registered Jack 45, the RJ45. It is the most common modern connector for Ethernet networks. The RJ45 uses an 8-pin modular connection with up to 8 wires being used as conductors. This is technically called an 8P8C modular connection, and it's used to transmit data over the network. Now, the RJ11 is the most common connector for telephony, and it's often used when networking over telephone wiring, or for when you're making telephone calls. The RJ11 uses a 6-pin modular connector with up to 4 wires being used as conductors. Technically, that's a 6P4C modular connector. Now, coaxial cabling can also be used to make a network connection, but it's not very common in today's local area network environment. So let's talk about USB versions 1 and 2. That's the Universal Serial Bus connector. Versions 1 and 2 use the same cables and connections. The basic types of connectors are broken out into Type A and Type B connectors. Type A USB connectors can carry power to the peripheral device as well as carrying data. Type B connectors do not provide power to the peripheral devices. The maximum length of a USB cable is 5 meters. So now let's talk about USB 3. It's a newer, higher speed version of the Universal Serial Bus. USB 3 devices use a different type of connector for peripherals. They're specific to USB 3. Earlier USB peripheral devices can use standard USB cables to connect to a USB 3 port on the PC. The USB 3 port on the PC is usually colored blue to differentiate it from earlier versions of USB. Now, as long as the cable matches the electrical specification, there is not a maximum length for USB 3 cables. Let's move on to the IEEE 1394 cable and connections. This is FireWire. Now, FireWire comes in 2 current standards. There's FireWire 400, which uses a 6-conductor cable with a maximum length of 4.5 meters. Then there's FireWire 800. It uses a 9-conductor cable and has a maximum length of 4.5 meters as well. Now, a connection that you might come across on a PC is the eSATA connection, the external SATA connection. This is a standard that brings the speed of SATA outside of the PC's case. Now, an eSATA port is a type of combination port. It combines a USB port with a SATA port. Now, it has not been approved by the organization that sets the USB standards, and it has not been approved by the organization that sets the SATA standards. So use an eSATA port at your own risk. So now let's move on to display device cables and connections. And we're going to begin with analog cables and connections, and the first one up is the composite RCA cable. Now, this looks like a TRS cable, but it can carry an analog video stream. The end result is the lowest level of resolution that you can deliver to a monitor. Slightly better is the S-video cable. It is a 4-pin cable that has better resolution than a composite cable, but still not very good resolution. Moving onward and upward, we have the component or RGB cable. Now, this is a combination of 3 cables. It breaks the color components of the video stream into 3 discrete channels. This allows for better resolution than S-video and composite. And finally, we have the VGA, the Video Graphics Array, which can also be called a DB15 or an HD15. Now, this is an analog display standard that uses a 15-pin D-subminiature connector. That's the DB15 connector. The pins are arranged in 3 rows of 5, which are fitted into a D-shaped shell. Now let's move on to the digital world, and we begin with DVI cables and connections. That's the Digital Visual Interface. Now, this is designed to carry an uncompressed video stream, which results in a superior image. Now, DVI comes in different versions. There's DVI-A. It can only carry an analog stream. Then there's DVI-D, and it can only carry a digital stream. To kind of bridge the gap, DVI-I was develop. It can carry either a digital or analog stream. Then we have the High Definition Multimedia Interface, HDMI. It too is designed to carry uncompressed digital video, but it can also carry audio at the same time through the same cable. It provides for a high transfer rate and with a very high quality image. It comes in two standards. There is the full-size HDMI, and it uses 19 pins. Then there's the mini HDMI. That's a smaller format, but it still contains 19 pins. Now, it's not as robust as the full-size HDMI, which means that it's easier to break. And finally, we have the DisplayPort. Now, this is a non-proprietary standard for transmitting high-quality video from a device to a display. It uses a 20-pin connection. Now, DisplayPort comes in various sizes, depending upon the form factor of the device that is transmitting or receiving the stream. Now, that concludes this session on cables and connections. We talked about internal cables and connections, then moved on to external cables and connections, and we ended up on display device cables and connections. Now, on behalf of PACE IT, thank you for watching this session, and I look forward to doing another one.